Hi, this is Bob Swanson again. I'm an astronomy instructor at ICC, and before we get into the Module 3 lab activity, I wanted to give you some another option. If you have a hard time understanding the simulation that goes along with Lab 3 activity, you may want to make a little device, a little more hands-on device, that does much the same thing that the simulation does. In fact, this is what I do when I teach astronomy to a traditional class. We build this hands-on device first, then we learn about the simulation. Sometimes it's a little easier to touch something than to abstractly deal with a computer simulation. So if you want to, it's not a requirement, but if you have a hard time understanding the simulation, you might find this device that might come in handy. And this device, of course, is a solar motion demonstrator. I'm going to give you a link that'll take you to the directions as far as how to construct a solar motion demonstrator, but I'm going to show you how this one works. Now, this is a solar motion demonstrator, and it actually has three different parts, really. It's got a blue disc, sometimes called the, let's see, what is it called? The frame piece. And then, of course, there's the horizon disc, that green thing. And then there's a little brad here, which is going to represent the sun. And so what you do, it's very, like I said, it's very similar to the simulator that you're going to work with in this lab activity, but the green disk, the horizon disk, is really like a little section of the Earth. So you're going to pretend that you're standing on the Earth at the black dot in the middle of this little green disk. And you can look out on any horizon. You can look north, you can look east, you can look south, you can look west. And so you're going to pretend that you're standing at that black dot. And you can choose your location on the Earth by changing the latitude setting. So if I want to be at the equator, I slide this down to 0 degrees. If I want to be in Fulton, Mississippi, I go in between 30 and 40 degrees because Fulton's latitude is 34 degrees north. If I want to go to the Arctic Circle, I go above 66 degrees north is the Arctic Circle. So, Barrow, Alaska, 70 degrees north. North Pole, 90 degrees north. So you can choose any location in the northern hemisphere by sliding your horizon disk along this little latitude band. The other thing you can do is you can change the time of year. If you want to see where the sun is on a particular date, you use the month little area here, and you just move your sun. This is that brad, the head of the brad indicate that represents the sun. And so you can choose your date. And so, I'm making this recording on September 17th of 2014. So I'm going to put my sun in mid-September. And the cool thing then is I can, by swinging this month piece, I can kind of represent the motion of the sun on a particular day. And so notice what happens. Remember, I'm standing on this black dot. That's me. Right? Do I see the sun right now? No. But then notice, oh, there's the sun. Where did it rise this morning? It rose almost due east. And it climbed in my southern sky until it was at its highest point. And that was at noontime. Local noon is when the sun is highest in your sky. Which way do I have to look? I have to look toward the south. I'm standing at the black dot. I'm looking south. I'm looking pretty high in the sky. And there's the sun. And I continue the sun along here into the afternoon, and notice where the sun sets. And pretty much due west. Then notice what happens. As it continues, I can't see the sun anymore, right? It's evening. By the time it gets back here, it's midnight. Now notice I do have to flip this around, but not only can you tell where the sun sets and rises on a particular date from a particular location, but you can also see how much time the sun spends above the horizon as well as below the horizon. And what you should be able to kind of figure out from this representation is, September 17th. Is there a very important date coming around? Sure, in just a few days, it's going to be the autumnal equinox. What does equinox mean? Equinox, equal night. Notice that on the equinox, the amount of time that the sun spends above the horizon, the day, is about the same as the amount of time it spends below the horizon, the night. So equal night, equal day. The day is about 12 hours long around the equinox, and nighttime is around 12 hours long. So those are some of the things you'll learn by building this solar motion demonstrator and playing around with it a little bit. And of course, these are the same lessons that the simulation is trying to teach you as well. So the next video, I'm going to actually go to the simulation and try to teach you how to kind of put yourself in the simulation and learn much the same thing. Like I said, some people find this more useful, at least as a start, and then it's a little bit easier to transition to the simulation. So if you want to build one, I will put the web address. It's the Lawrence Hall of Science that actually has the plans for building one of these things. Really easy to do. Takes a little bit of glue, a little bit of, I like to use cardstock to make my frame piece and my horizon disc, and then a little brad. And you can improvise, and if you don't have that stuff handy, use something else to represent your sun. But just kind of play around with it and get a feel for the fact that the sun does not always rise or set due east and due west. In fact, only twice a year does that occur. So it doesn't, we get lazy and we say the sun rises in the east, it sets in the west. Not due west, not due east. So you'll get a feel for the fact that the sun does change its position during the course of the year. And because of that, it also climbs to different elevations in the sky during different times of the year. The amount of daylight hours changes during the course of the year, and of course all this is also variable depending on where you're at on the Earth. So I hope you enjoy it. Like I said, look for the link and look for the next video.